everyone, my name is Shambhavi. Hope you all are doing well. So we were going to the discussion of 1 second. I would just put on the cursor right here, right? So we were going on a discussion for the calculation of sum of squares and the mean square, right? This was what we were doing that discussion for. So on to that we had seen out the several parameters. I would not give you a revision of that right here. We'll be discussing that at the last, right? First let me finish up all of those parameters, all of the steps, all of the things which we are having here, okay? So what I'm going to do is that let me start on with the color and let's start out with the writing of some stuffs right here. So let's take out this one and let's proceed on. So yeah, here we go with the number that's 11, right? Previously we had sorted the 11 number that was 10th. So now here what I'll be doing is that I'll be starting with the 11 number, and into that particular we are having some different means as well to go ahead, okay? Now I'll be talking about the degrees of freedom right here in the starting. So I'll be talking about the degrees of freedom, that's the DFs, right? So the DFs for the different groups, okay? I would just discuss about the DFs for the numerator. So DFs for the, and here goes the numerator. So numerator. Fine. So for the numerator, what is the DF? And put on the colon. Here goes DF and this. Okay, not F in the denominator. It's like DF like this, and between in the denominator. Okay. So between is equal to K minus 1. Okay. So yeah, hope I am clear with this particular thing. First of all, for the DFs of different groups, that what's the formula? So that is DF between first of all, and that is equal to K minus 1. Right now, next coming to number 12, we have the equation for errors, okay? So here we have equation for errors within samples, equation for errors within, and here goes the samples. So equation for errors within samples we are having, and that is basically the DFs for the denominator, DFs for the, and here we have the denominator, ds for the denominator, fine. So ds for the denominator we are having out here. So let me go down. So equation for errors within the samples, and we have then dfs for the denominators. So into that we have just put on like this, and here I would mention out df, and that is for the within, okay? Numerator one was for the between, and for the denominator we have within, right? Putting on the equal to sign, and here we have n minus k, okay? Yes, so that is again as well sorted out. Now let's go move forward and let's see regarding other ones. Now we'll be dealing with the mean square. 1 second. So right, so the mean square, that is the variance estimate as well, you could say, but I'm not gonna write that things. So simply goes a mean square explained by the different groups. So yes, this is the one, that is the mean square explained by the different groups, okay? Now into that we have ms between, downside goes the between, right? And that is equal to, let me just come down right here. So it's ms between, that is equal to, we have ss between and divided by df between, right here. So like this we are having. So that's the mean square explained by the different groups. So for that we find out ms basically means the mean square, and between is basically the first category which we have. So for that the formula which we are having, it is ss between upon df between, okay? Now let's move towards number 14. So 14 we are having mean square, that is again I would say this is the variance estimate. So mean square I would write that is so it is due to, so mean square is basically due to chance, okay? Now into that we have ms, and here goes the within. So ms within, that is equal to, here we have ss within, ss within divided by df within. Fine. So for here as well, we are having out the mean square, that is basically due to chance, which is ms within is equal to ss within upon df within. Fine. Now ms and basically df can be written in one another way. I would show you. Ms between, sorry, the ms between and the ms within. Okay, the ms between and the ms within can be written, basically in two ways. I will show you. Can be written as follows. Okay, so here for the first one, that is the a, we are having ms between, that is equal to ss between divided by df between. Okay, we have ss between divided by df between. Fine. And now that is equal to ss between divided by k minus 1. Okay, so yeah, right here we just put on the things like this. Let me just go down. For the next part, that's the b part, we have ms within. Okay, that is equal to ss within divided by df within. Okay, now that is equal to ss within divided by n minus of k. Right, so this one is as well written out here. Fine. So I would just now I would go over for a while. 1 second. So these were the calculation of the SS, that is my sum of squares, and MS, that is my mean of square. Let me quickly give you an idea. So K is basically equal to the number of different groups. Okay, Nj is equal to the size of the jth group. Sj is equal to the sum of the values in the jth group. N is equal to total number of all the values combined. X is equal to one value, and that is a sigma x is equal to sigma s of j. Fine. Next we are having sum of squares. Of all values from every group combined. So that is sigma x square. Right. Then we have between group variability. So that is SS total. The formula we use is for the SS total, sigma x square subtract minus, that is minus sign. Then on to the numerator, we have sigma x whole square and divided by n, that n is in the denominator. Okay. Now next we are again having out total sum of squares, that is again same, sigma x square minus sigma x whole square divided by n. Fine. Then we have the explained variation. So that is the sum of squares representing the variation among the different samples. So for that we have SS between is equal to sigma Sj of whole square divided by Nj minus, in the brackets we have sigma Sj of whole square divided by n. Right. Next we are having the unexplained variation. So that is the sum of squares representing the variation within samples due to chance. So that is SS within is equal to SS total minus SS between. Fine. Then we saw about the DFs for the different groups. So DFs for the numerator, that is the DF between is equal to k minus 1. Right. Then we saw equation for errors within the sample. So DFs for the denominator, DF within is equal to n minus k. Then we basically have the mean square explained by different groups. So that is ms between, that is equal to ss between divided by df between. Fine. Next we are having mean square, that is due to chance. So ms within is equal to ss within divided by df within. So ms between and ms within can be written as follows. Okay, 1 second. Can be written as follows, that is ms between is equal to ss between divided by df between, which is equal to ss between, you could even write out divided by k minus 1, that as well works. Okay. Now next we have ms within. So for ms within you have ss within divided by df within, that is equal to ss within divided by n minus k. Right, so hope I made this particular thing very much clear to you regarding the calculation of sum of squares and the mean square. Now we'll be seeing some more things in the next video. So this is all for this video. Till then, thank you and take care.